Hi everybody, welcome to the first lesson of Module 3, which is on probability. I want to take a minute to explain why we need to cover probability in this class. And that is that we're going to use it later. We're going to spend the entire second half of the course doing statistical inference. And if you remember, statistical inference is when we're using information in a sample to make generalizations about the population. To be able to make some of those leaps, we need probability. One of those leaps that we'll make is when we're trying to determine whether something like a relationship between two variables actually exists. So we'll look at a sample, and if we see a relationship there, we're going to ask ourselves, is this a strong enough relationship that we can reasonably conclude that that wasn't just due to chance? So anyway, all of this is building up to that, to build the foundation of statistical inference. So we're going to do 3 really quick sections in today's videos. And we're going to start with random variables. So a random variable is really just a variable that we assign a random outcome to. Now, it's not completely random, though. These things have what's called distributions, so that, some outcomes could be more likely than others. But I'm starting to get a little bit ahead of myself. Usually in this class, when we talk about a random variable, it's usually something like, we randomly selected 50 days in Charlotte, and we measured the high temperature. Those 50 days are 50 values of a random variable. Those are 50 realizations of a sampling process. And you might call that the outcome of an experiment. It's not an experiment in the sense that we talked about before, where there's a control group and the researcher's manipulating, but it's an experiment in the sense of we're selecting an observation and noticing what the outcome is. So these are 3 examples. If we randomly select a day and we look at the high temperature in Charlotte, that's one example. And one way you know is that if you pick a different day, you're likely to get a different high temperature. Okay, unless there's just some weird coincidence, you're likely to get a different high temperature. The number of eggs broken in a randomly selected carton. So if I go to the grocery store, pick up a carton of eggs, and count the number of eggs in that are broken, that's going to be a random variable, because if I pick a different carton, I'm likely to get a different number of eggs broken, or at least I might. Finally, the time required for a person to drive from the Charlotte airport to the Atlanta airport. I didn't put in the phrase randomly selected in there, but still, that's going to depend on the person doing the driving and the decisions they make. It's going to depend on the weather. It's going to depend on the traffic. It's going to depend on lots of factors, which are going to vary from time to time and person to person. I think in this case, it's just as instructive to look at non-examples. So some things that are not random variables. And if it's not a random variable, it's called a fixed quantity. So something like the boiling point of water on the Celsius scale. That is 100 degrees Celsius. That is what it is. That does not vary. The number of eggs in a small carton. Those small cartons always hold 6, so that does not vary. And finally, the distance from the Charlotte airport to the Atlanta airport. And let's assume that it's as the crow flies, as they say, so that we don't have to get into, well, there's different routes or whatever, but the distance is what it is. It doesn't vary based on who's driving or whatever. So those are all fixed quantities. It's important to be able to classify random variables by whether they are discrete, and that's discrete with an ETE. This discrete means separate or continuous. A continuous random variable is one where if you had an accurate enough measuring device, the values could go out to many, many, many decimal places. We usually don't record them to that many decimal places, but these are usually weights and measures. So if you had a scale that could measure something to a degree of accuracy of 100 decimal places, in theory, a weight would go out that far, or farther if you had an accurate enough scale. So anytime you see, though, a weight or a measure, and that includes time, that's going to be continuous. A discrete random variable is just kind of the opposite of continuous. We said that essentially means separate, which means that the values can't theoretically go out to many decimal places. These are usually restricted to being whole numbers. The only example might be if you're looking at shoe sizes, where those can be halves. But other than that, these are almost always whole numbers. And these are usually frequencies, like counts. So you're counting the number of traffic accidents in North Carolina in a day. Or you're counting the number of city council people who voted for something. Even though that's not really a random variable. But if you're counting something else, anything you're counting is likely to be, anything you're counting is going to be a discrete random variable. And the reason this is important is that the way we look at distributions, the way distributions are written, is different based on whether they're continuous or discrete. Today we're going to talk about discrete random variables, or distributions of those. And later on we're going to look at continuous random variables, but not today. So some examples, and then we'll talk about which, for each one of these, if it's discrete or continuous. The number of employees a company has. Well, that's a frequency, that's a count. That's the result of counting. So this is going to be discrete. The percentage of people in a town who have health insurance. That can go out, theoretically, to infinitely many decimal places. So that's continuous. The weight of all of the freight on a commercial flight. That is a weight. We said weights and measures are continuous. And finally, the number of passengers on an airplane. That is the result of a counting process, and those are always discrete. All right, so that is really all there is for section 5.1. Section 5.2 and 5.3 will be almost as quick, I promise. So that's it for this lesson.